So we're down here today at the Georgetown Steam Plant. Natalie and I came down here for the Phonographers Union event back in October, and then couldn't make it because I was in Academy for their monthly open house. So we're here today, and we brought Scott, who did steam type things in the Navy, to explain to us what we're looking at.
Hopefully.
So we'll see how this works.
Thank you.
This is interesting.
It's auxiliary generator?
I believe it's a pump. This end's a steam turbine. So this is the hot end. And these would be probably 3 impellers on a big centrifugal pump. There's a large manifold inlet flanges over there. So yeah, more moving water to
Feed water pump, maybe?
feed water, condensate, water for some part of the process. That's big.
That's what she said.
No, I've never had that experience. Not in my wheelhouse. What they call generators in this era, Chris? Do they call them magnetos?
Only if you were in the UK, I think. I think they were just called generators.
Continuous current generator.
It was playing 1907.
This is from 1907?
Yeah. And what this machine was for was taking some of the 13,800 volt 3-phase AC from the generators and making 600 volt DC for trolley cars and the interurban trains from Tacoma and the overhead crane, 50-ton overhead crane.
Okay, I was going to ask what they use 600 volt DC for. I was looking at it, DC generator. Okay, that's interesting. Is that just the output breaker there, the big knife switches?
They're disconnect switches, and both for the output and also for the equalizer bus too, because there's a second unit right beside that one over there. There were 2 of them, and both could produce 1 megawatt.
Okay. And so the equalizer was for paralleling them?
Yeah, because what happens is if the field excitation is too high on one, you could get circulating current, and so the equalizer bus connected the 2 series fields to divert over excess field current on the stronger unit over to the weaker unit.
Okay. Sort of like the procedure I had to use in the Navy to parallel 2 generators so they were working in phase before you brought a new generator online. Except this is DC, not AC.
Yeah, DC. And on DC, you still have to have the voltages equal.
Yeah, the voltage has to be equal. You usually have to have it in phase because there is no phase.
There is no phase on DC.
Yep.
Equal to within how close of a tolerance?
It depends upon the machine, but what happens is if you have one machine overexcited, you're going to get a circulating current in the weaker one, and then also, too, you could possibly end up motoring it and causing damage. So.
Okay.
And there were 2, like I said, there was a second unit right over there, and where the polyethylene is. There's in that little area here, and they took the second unit out about I think that it was about the 60s too, and it was good. It was taken and sent to the Puget Sound Railway Historical Association's museum because they were going to use it, but they never did because the Puget Sound Railway Historic Association in Snoqualmie folded into the Northwest Railway Museum. And they were going to use it to convert three-phase AC into 600-volt DC. They had two DC electric railway interurban cars they were going to run, and then Portland Traction streetcar too. And then also they got one Seattle Transit 1940 twin coach trolley bus too.
Okay. They're going to run all those off the 600 VDC.
Yeah.
Okay.
So this is obviously, I worked on steam plants in the Navy, but not reciprocating piston steam plants. This is obviously a large flywheel attached to the piston edge
That
there.
was for pumping air out of the steam condenser.
Okay.
It's a reciprocating vacuum pump, but the generation is steam turbine.
Okay.
And the GE Curtis steam turbine, which these are example of, that was the first practical steam turbine.
So is it a vertical steam turbine?
Yes.
So this is the turbine right here.
The turbine's the silver part up above is the generator.
Okay, that's the generator, that's the turbine, this is the boiler, and
The
it's just
boiler's
straight.
in the boiler room.
Okay. And then is that
Air cooling duct.
air cooling duct? And then the large pipe over there
Is
is
the outlet from the steam turbine to the condenser.
to the condenser. Okay. So we used steam nozzles and induction principle to remove the air and non-condensable gases from the condenser. But this is using a reciprocating vacuum pump.
Yeah, it is.
Okay.
What you have there where you're using steam nozzles and stuff is kind of an aspirator.
Yep. So that's actually the pump
The pump is the big cylinder
at
and
the far end.
Yeah.
So what's driving this? That's the
Okay.
pump. Oh, I see.
I'll show you. This is your pump here, and you have a steam engine cylinder that's driving both the pump and the flywheel. And
Oh.
This is your engine here.
Okay, so I was looking for the engine to be by the flywheel. So the steam piston here, vacuum pump, flywheel. So once the assembly's rolling and up to speed, it's more self-sustaining.
Yeah, because what they do is the shaft comes out of the opposite end of the pump and continues to a crosshead.
Yep.
And then you have a connecting rod to an eccentric shaft, the flywheel. And
Yep.
then you have two eccentrics here, and one eccentric is used to operate this valve here to switch port from
Yep.
when the piston finishes one direction of travel.
It shuttles the
then-
valve.
then it's going to switch ports to direct steam to the other
To the
side.
other side of the
And the
piston.
previous side to the outlet.
That's right. So this rocker and these
Yeah.
arms are controlling the valve here.
Yeah, it is, yes.
Are these sleeve valves?
It's what it is, it's a slide valve, a D slide valve. And that's a vacuum gauge.
Yep. Vacuum gauge, thermometer. These are neat. I love these old drip boilers.
Yeah, you've got to keep the moving parts lubricated.
Yep. And Chris, you know what modern phrase comes from this item here?
Running
Of course,
balls out.
Yeah, going balls out because of the governor.
And in the diesel fire trucks that we drive, the diesel engines have a governor of 5 volts that work against the spring setting.
Yep.
Diesel engines, you cannot run without a governor, whichever make you have.
Well, right now the new ones have a a giant 12-liter Cummins that's all computer controlled, but the older ones with the manual injectors had a governor built into the injector pump, I believe.
I wish we could get one that worked right, or at least a pump governor that worked worth a damn.
Yeah. But, and then you have another eccentric which goes to the valve on the pumping cylinder that switches ports so that no matter which way the piston is going, you're always pulling air out.
Right.
And so now she's shoving it back into the condenser.
Right. So you're drawing it back in both ways.
Yeah.
And where is the condenser?
The condenser is...
In the next room over?
No, it is... the condenser is this big thing right here.
So this tower is the condenser.
It is, yes. And here's your steam turbine outlet.
Okay. So this is the exhaust steam coming out here and going up, and then into the condenser up there.
Yeah, it does. And then cooling water from a pipe on the other side, from a pump house over on the Duwamish River, goes in the uppermost part, cools the steam down after it flows through a nozzle tray inside. And
Right.
then the water comes down into the hot well and then into the condenser pit and back to the river.
Okay.
And
So to keep the steam side separated from the raw cooling water from the river, is that like a shell and tube heat exchanger with the river water inside the tubes, the steam on the outside?
no, they're both inside. This is an older design. It's not a heat exchanger like newer designs.
Right.
This predates the heat exchanger.
Okay.
And
So does the water mix, or what?
it kind of does, yes.
Okay.
And like I said, you have a vacuum pump because there's going to be entrained air in the river water. And
Okay.
once you get the air out, you're going to raise the vacuum from about 26 to 28 inches.
Yep.
And there you've got very efficient operation.
Yeah. The lower the pressure in the condenser, the more efficient the steam turbine is, because you get more of the energy back out of the steam.
Yeah, because you're not pushing against atmospheric pressure.
Yep. Yep. Interesting. I've never, well, all my experience is marine steam plants, so you do things different when it's shore-based. The vertical condenser is interesting. The vertical turbine's interesting. So I'm used to all those things being more horizontally mounted.
And what happened was, GE, Charles Curtis was the first person to come up with a practical steam turbine power generation. He worked on it from the last part of the 1890s until 1901 and built several prototypes, a few prototypes, and then GE accepted his design, and Curtis went to work for GE, and his supervisor, Leroy Emmett, wanted the vertical design to save space to reduce the amount of land that the plant occupied. And so the first GE Curtis steam turbine generator came online in 1903 at Newport, Rhode Island for the Nantucket Railway.
Okay.
Street cars. This is a newer condenser here, a volume that is the only function generator.
So this is another condenser.
Yeah, and that is a horizontal turbine right above it.
Okay, so the turbine for that one's up above.
Yeah, and after...
This was installed after this, then?
Yeah,
This is a newer design?
It is, yes. The very first one all the way over was installed in 1907, this one 1908, and this one 1919.
Okay.
GE went to a horizontal design after 1913.
Okay.
And
I ran GE turbines mostly for the Navy, and it's interesting you talk about Curtis that invented the first efficient steam turbine, and you know a Curtis stage and the way that a Curtis stage works was one of the first things I learned in steam turbine mechanics school for the Navy.
my dad worked at a power plant before I was born in Kingman, Arizona, and his was the Kingman plant's turbines were Alice Chalmers Parsons. And Westinghouse and Alice Chalmers used the Parsons design.
Okay, I'm not familiar with that design at all, but I know there were several different designs in the beginning of steam turbines.
Yeah. And what happened was the very first design in 1882 was a Diva valve, and it was a single-stage steam turbine.
Yep.
Nozzles that jetted steam against the stage, and not very efficient.
Yeah. So we use De Laval turbines or De Laval style turbines for fire pumps and some of our steam-powered pumps, where it wasn't a direct condensing turbine. It went to an auxiliary condenser, and you had a turbine just driving a single unit. Not very common on ships anymore because everything, all the small pumps and stuff were electric. My first ship we used some De Laval turbines.
Yeah, and we have two De Laval turbine pieces of equipment here in the plant. One of the steam turbine exciters.
Okay.
And the exciter provides direct current for the fields of the main AC generators.
Okay.
And also for the field on the synchronous motor generators. And then we have a De Laval steam turbine driven feed water pump here.
Okay.
And then there's
Where's that feed water
yes,
stuff at?
we can't get to it.
Oh,
it's closed
okay.
off, but it's in the next room down on the wheel.
Okay.
And then we have a Terry steam turbine, which is
Go ahead.
extracts the dirty water and move it through the jet volumetric condenser, the cooling
Right.
water. Yeah.
Okay. And that's what that is. That's a Terry turbine over
Yeah,
there.
it is, yeah.
Driving this pump.
Yeah, and
Okay.
also it's driven by a two-phase wound rotor induction motor too to balance the load.
Okay, so that's the Terry turbine,
And then
the
the
induction
two-phase-
motor, and
Yeah.
then the pump.
Yeah,
Okay. I'm Scott.
I'm Ted Snyder.
Nice to meet you, Ted. I appreciate your
Chris
being
Camp.
here and the
Yeah.
education today.
And one thing too, I finally wrote a paper about my dad's role in as an electrical pioneer on Route 66, which went from LA to Chicago.
Yeah.
And the King in Arizona was on the route, and the plant was needing expansion. And the plant already had one 2.5 megawatt Alice Chalmers Parsons steam turbine and two Alice Chalmers generators driven by Nordberg cross compound cordless steam engine.
Yep.
And he got a second 2.5 megawatt steam turbine secondhand from a coal mine in Illinois and put it in to provide added capacity.
Okay.
And then later on, he added 69,000 volt transmission line from the Pioche, Nevada switching substation for Hoover Dam power to Cape.
Okay.
That added a transformer to step it down.
Okay. So you wrote a paper on that?
Yeah, I did.
Is it available online somewhere?
I have it here in the plant.
Oh, okay.
And I'll tell you something. Those were good days for my dad. Better than when he came to Bowling.
Yeah.
I don't know why. His life deteriorated up here once he died to Bowling. And end up having a drinking problem.
Well, that's unfortunate. It sure sounds like he was an innovator in early power distribution in the Southwest.
Yes, and my dad, when he was actually even in high school and college, things were changing in the power system to what would be now. And also, one of the other big electrical technological improvements that came to was diesel, using the electric transmission for diesel trains and locomotives.
Right.
Because when he got to working in Cayman, the Atchison, Topeka, and Santa Fe used diesel locomotives on their super chief for the train from
Right.
LA to Chicago, and that was
E8s? E7s and E8s, I think?
E3.
E3s. Okay, a little earlier.
So was that direct gear diesel as opposed to diesel electric?
It was diesel electric.
Okay.
Direct gear is not practical. Mechanical transmissions aren't practical.
On trains.
And Three railroads at the time went with that. Besides the Santa Fe, so did the Chicago, Burlington, Quincy, and also the Union Pacific. And the start of that right there in the 30s was the beginning of Detroit diesel.
Okay.
That was also still EMC at that time, before it was EMD. Yeah.
But Detroit diesel emerged right in the 1930s. Charles Kettering was the inventor of the two-stroke diesel engine
Okay.
used by electromotive.
All right. I think we're going to wander around and look at some more of this stuff. Thanks for the education and your time, Ted.
You betcha.
I would like to build a scale model steam engine like that sometime.
We have everything to do it.
We do. There's also kits available.
I've got the lathe. We don't really need a mill.
This? Not exactly. I mean, it's basically a gasoline engine in here, and there's valve gear that so when these slow down to a certain amount, it causes fire. I've seen plenty of old farm portable farm engines like this, but I'm not sure. I'm not sure how this valve gear works. If you watch this valve, see it'll move once, boom, and it'll fire the piston.
Right.
So that's a governor in there, and it senses when this is slowing down and fires the piston. So if there was a load on it, these gentlemen might know how it works. They look like they know things I don't.
So that's the steam helps keep it going or something? Like, I'm missing something.
It's gasoline rather than steam.
It's just gasoline.
Alcohol, probably.
Oh, I see. Okay.
And these all would have been driving something off a big flat.
Over here.
I'm not lost, I'm just over here seeing it. So this was what was he saying, Chris? This was
The first turbine.
first turbine. And again, I'm assuming that the silver area is the turbine and the concrete down here is foundation.
Yep.
And then that would be the electric generator up there.
Yeah, and I know that's for the
Vertically
part of
mounted.
the throttle valves. Is that?
Oh, yeah,
that
that-
whole assemblage up there.
Yep,
We
sure
can
it
go
is.
up to the upper level and get a better look at
we'll
it.
Get there. And this must be another vacuum pump, just like the vacuum pump over there, performing a similar service to make the plant operate efficiently. So obviously another. What's the purpose of this pump?
You're asking the wrong guy.
Asking the wrong guy.
That's a Ted question.
That's a Ted question. Well, he would know. Obviously,
I can make something up. But,
obviously, steam lines, steam cylinders and pistons, connecting rods, and some kind of pump there again, Chris.
Air compressor of some ilk.
Good, yeah, could be an air compressor. Those are relief valves, right?
They look like relief valves. Yeah,
Those are relief
PRVs.
valves. Could be an air compressor, and connected valve gear, shuttle valves, sleeve valves in here to run the steam pumps. Sure.
Take a look at this valve assembly.
Yeah. Right there.
Oh yeah. No idea if that'll show up, but
I wonder if that's some kind of a condensate drain assembly to get siphon moisture out of the steam lines before it goes into operating.
well,
the
it
pump.
taps in. The two of them come together and tap in up there, so I think that's a good bet.
And down here.
And down there,
Yeah.
which are not exactly low point drains, but
Yeah, it's
it would make
interesting.
sense of a drain down.
Yeah.
He explained to me what those were for last time I was here, and I've now forgotten it.
Huh. I have no idea. I mean, great big heavy discs.
Yeah, they hold something down, and then it's like a surge protector or something when it starts up that keeps it from jumping up or something. But
It's an accumulator for
oil
oil.
accumulator.
So the vertical turbines are supported on, the shaft is lifted by oil.
Okay.
And if the oil pressure goes away, the shafts jam.
Okay.
So it gave a little bit of time if
Okay.
the oil pump stops.
All right. Thanks.
Right. So we used oil accumulators and fuel accumulators in the Navy that had a tank with a bladder and air pressure on one side. So if you lost a fuel oil pump, the air pressure pushing against the bladder would push the fuel oil out of the tank or out of the round accumulator and keep the boiler burning so you could get the fuel pump back online.
Right.
We used the same thing for lube oil if we lost a lube oil pump. So I'm guessing that has oil in it, and the weight of those plates pushing down, if you lose your oil pump, those plates pushing down continue to force oil into the bearings probably.
Yeah, because the whole stack, the whole
Yep.
turbine and the generator is resting on a shaft,
Yep.
which is supported by that oil, and so the weight of the plates there
Would,
keeps it pressurized, keep that up in the.
like if you lose the if you lose your boiler and lose steam and the steam driven oil pump quits turning, the weight of the plate stack settling down continues to force oil through the bearings.
Which may be
Down to a
what
stop.
may be what those pumps were.
It's interesting, we had a lot of these in the Navy for valves you can't reach. It's nothing fancy, it's just a piece of steel with a valve hand wheel and two valve hand wheels bolted together. The inventive stuff guys in steam plants do to keep from having to stand on something to open a valve. So we had a lot of our, on my ships, we'd have fire pumps and stuff that would be powered by a single stage steam turbine, which is what this is. And then that's powering, we'll look at the output in a minute. So the smaller pipe is steam inlet, right? Higher pressure, smaller volume. Larger pipe would be steam exhaust, and this would go to a condenser of some sort. And then this valve gear, this is steam into the turbine to turn the turbine. This is attached to the shaft, and this will be some kind of probably a constant speed governor. So the faster the turbine goes, this would push out against spring pressure, causing a force in there to close down on the steam ignition valve. Right, so it operates at a constant speed, and then this is probably a manual trip or a manual. It's either a manual trip or you pull it to get steam going in to get it started till you get RPMs and get your governor in service. It's not that dissimilar to what was still being used for steam tubers in the 60s. When ship's ice steam were built.
Pressure relief valve here.
Oh yeah, casing relief. Casing relief, because if that valve's shut and you let steam in, it wouldn't take very many PSI to generate tremendous pressures against all the square inches of this case. Yeah, so casing relief. What are we doing with this turbine?
That looks like a feed water pump. Or a condensed, because it goes up
So
into the
that's
bottom of the...
temperature. That's the thermometer. And we've got something out of the bottom of the casing, something into the middle of the casing.
Pumps it from...
It's vacuum gauge, so
Yeah.
it's a vacuum gauge, so
Must be a pump to the condenser.
yeah. Or there's a lot of removing. There's a lot of work done to remove air and non-condensable gases from the condenser, because you're always getting air into your system and there's gases that won't condense, and what you want in there is pure steam condensing to pure H2O. So being as we're dealing with what's essentially a turbine-driven vacuum pump, quite possibly it's doing the same thing that piston pump did over there, which is removing air and non-condensable gases.
So
from the
basically we're looking for a steam-powered vacuum pump.
Yeah. Yeah, and these cool ass little, some of this stuff I have to just get some stills of for people. The little oiling cups. We had a few pieces of equipment that still used things like that, so every watch you'd go around and fill that with oil, and then screw this down into the hole. And then this would be a little micrometer valve controlling the oil feed into the bearings. You'd look through there with a flashlight and make sure you had a steady drip, drip, drip. It's much different than the drip, drip, drip of gonorrhea. It's just the drip, drip, drip of oil. Cheech and Chong joke, I think. But anyway.
Shall we go up?
We shall. See, this is almost the same governor setup on the inlet of the Terry turbine. So steam in, steam admission valve into the turbine, and then this is going to, at operating speed, force this out, which forces that in, which controls steam. Then if it's slowed down, it would work the other way, right? Increase loading, generate more steam. This is probably a trip lever to shut it off manually in an emergency.
Probably the last time it was overhauled.
Yeah. And this is probably an
Oiler for the shaft.
Oiler for the shaft. And this is probably an oil level indicator. Some of these had a little oil sump under the shaft. You'd have bearing, and between the bearings you'd have a brass ring that just floats on the shaft and spins and dips down into the oil sump and flings oil up onto the shaft.
The boundary layer will grab it, and the boundary layer
which
adhesion, and
rolls out into the bearings. The propulsion shaft bearings, low-speed propulsion shaft bearings on Navy ships are oiled in a similar fashion.
any idea what that is? Is that a heat exchanger, or is that's electrical gear?
I have no idea what that is. I think it's electrical here. I don't have any idea what it is.
It's probably like a selenium rectifier or something.
I wonder, Chris, see that plate on the condenser there?
Stand by. Which one?
That handhold plate that's where the handhold's open where you can reach in.
Right.
It says Wheeler, New York. Foster Wheeler Corporation made a lot of boilers.
Yep. And nuclear reactors.
And I worked on Foster Wheeler boilers. Well, that Wheeler Corporation in New York became Foster Wheeler later.
I suspect
There's
you're probably
not that
right.
many coincidences in industry from the early part of the century. Or I guess the early part of the last century.
Early part of the last century.
Yeah.
This is so different in the daylight.
So, obviously, this is the electrical generator here, horizontally mounted. This is the steam turbine, and then it exhausts downward, which they determined was more efficient, into that condenser that we saw below. So that condenser probably has horizontal tubes with river water flowing through them, and the steam comes out of the bottom of the turbine, hits the outside of those relatively cool tubes, condenses back to feed water, and goes back to the boiler room.
I don't think they used recycled. I don't think they condensed their water and reused
Maybe
it.
they just use raw
Just
river
used. I
water.
think it was just the raw water system.
But then that vacuum pump down there that we were looking at would have served the purpose of maintaining the vacuum in the condenser for the efficiency. Oh, we can't go up that ladder, bummer.
That's going to be the throttle valves up there,
It is.
coming off this main steam pipe here.
It is. There would be a valve chest, and as you turned a hand wheel, those would open sequentially, probably. It's way different than what I worked on, because all this stuff is constant speed, right?
Right.
And this, well, we had electrical generators, so they were on a constant speed governor. But the big stuff that I worked on, was running a propulsion turbine, and so that was variable speed. But obviously, that's your steam coming out of the boiler plant, and this is a steam stop valve. And you can see how there's a gap there. This is the valve stem that actually goes into the valve and shuts it off, and this is connected to this operator. And I'll bet you would open this manually one turn at a time. But see this trip? I'll bet in emergency you would raise this, which would DC this hook from this pin and let the valve slam shut.
Yes.
So this would be a, oh
fuck.
Things aren't going well.
This is the bad day lever.
And this, I'm absolutely sure with the spring mechanism. Oh yeah, there it is. So turbine rotation activates mechanism in here, causes that beam to be tilted. This probably has oil pressure under it, and then this rod going up and down through that rack and pinion would operate the steam admission valve. Probably controlled by this linkage and physically lifted by oil pressure under a piston here, because you need significant force to operate those valves. So a mechanically controlled hydraulic piston off the lubricating oil system through the turbine, operating the steam inlet valve, which is exactly how we fucking did it in the Navy, really.
So what are the gauges here telling us?
These, well, that says steam, so I'm sure that's steam inlet pressure from 0 to 300 psi. So that tells me that in the era of this thing, it was considered a high pressure turbine. In fact, I think still in, like stationary industry,
Right.
anything over 100 psi is a high pressure turbine. First stage, this is going to be the steam pressure into the first stage of your turbine, or basically what's coming out of the nozzle block into the turbine, right? And you're never going to get the whole 300 psi going in there. 150 psi into that first stage is a big load. This is another pressure gauge, but I assume it's pressure 0 to 100, but
Lube oil pressure or something like that?
probably be oil pressure, sure. But this would be the guy in charge of keeping this thing operating safely would be standing here. What do we got here? So we got a hydraulic gear pressure gauge, bearing, and water pressure. So bearings, that would probably be oil pressure to the turbine bearings, and hydraulic gear pressure is probably oil pressure to the hydraulic control system. Mercury steel tube thermometer. And this is labeled oil cooler, and this is labeled thrust. So the oil system on here obviously has a heat exchanger to keep the oil from being too hot. So that'd be the oil cooler. And since somebody wrote thrust on here, I'm 90% sure that's probably the temperature of the thrust bearing.
That would make sense.
The steam hits one side of the turbine and makes the turbine spin. But the steam's coming at the turbine from the side, so it does generate axial thrust. So there's thrust bearings either in here or on the back side of the turbine, between the turbine and the generator, because that turbine wheel can't move more than a couple thousandths this way and that way without horrible things happening.
Rampant badness may ensue.
Yeah, horrible things. 10,000 kilowatts, 1,800 RPMs, patented in between 2002 and 2015, direct condensing, 200 PSI, so that's the maximum pressure you can put in it. Except as a prime mover for marine and aerial craft. There's your sign.
There's your sign.
Here's your sign, sir. I wonder how many stages this is, because this is essentially the turbine right here.
Can you look in there?
In the case, no. This probably weighs 500 pounds.
Yeah, it's not all. Oh, I guess that wouldn't help. I was thinking not all the holes are filled, but that only goes into the casing.
Yeah. I don't think you could get a view. There's probably 3 or 4 rotating turbine wheels in here. I know the stuff we use in the Navy would have a set of rotating blades and then a set of fixed blades. And the fixed blades would just redirect the angle of the steam for proper angle of attack on the next set of rotating blades, because the blades are like little airplane wings, right? I'm sure it's a multi-stage turbine of some sort. And here, PSI, probably oil pressure,
Bearings in there.
Yep. So on the ones we had in the Navy, underneath this cap is the bearing,
Right.
and under this hole would be under this plug would be a straight hole through the bearing cap down to the turbine shaft, so that you could put a depth micrometer in there and measure the relative height of the shaft.
Is that the run out? How much it's?
It's actually bearing wear.
Okay.
So what you do is you take the bearing apart, you'd measure the ID of the bearing, then you'd measure the OD, outside diameter of the shaft, then you'd put it together, and then you'd measure the distance from that machine flat spot down to the turbine shaft, and then that would be your standard. And then every 6 months you'd pull that cap and measure down to the shaft with the turbine stopped, no oil in it, right? And so that would tell you if the shaft was getting lower in relation to that flat spot, that would tell you that your bearing was wearing.
Right.
So that's how you'd monitor bearing wear, and if that shaft moved vertically more than X thousandths of an inch, like 3 or 4 thousandths of an inch, the bearing had to be replaced. And I assume it's a similar deal. 500 amps, 1,800 RPMs, 10,000 kilowatts. It's interesting the voltage numbers they picked for electrical transmission.
How so?
Yeah, no, it's pretty arbitrary, right? The higher the voltage, the less the amps that have to flow through the line, therefore the less heating and the less losses, right? That's why we transmit at high voltage.
Right.
But why'd they pick 13.8? Who the fuck knows?
Some multiple of something else, no doubt.
Yeah, some multiple of something else that made things work. And I've never seen a vertical steam turbine This is fucking cool. Obviously, the same steam admission piping over there, and the same poppet valve assembly for steam admission that's up there. Somewhere, maybe at the far end, that mechanism over there might drive the rotor that controls the valves. But I didn't know they made vertical steam turbines, actually. So obviously the steam must come in, flow down through the turbine, and then down into the condenser.
Isn't it up?
No, the electrical generator
That's
is above it.
the generator. So
That's
is this
the
cooling?
Cooling air for the electrical side. That's what Ted said. That was a cooling air duct, so I assume that's for the
generator.
electrical side.
Well, which is interesting because none of the other ones have it. So clearly, whatever the generation this was, needed cooling on the generator, whereas the other ones didn't.
Yeah, but like this one, Chris. Somewhere, maybe underneath, there's going to be cooling air inlets and air is circulating.
Right.
Maybe they found a way to make this one self-cooling, right?
So
What do we have here? It's probably the exciter coil.
yeah,
Probably the exciter coil that generated the field current.
can you explain how that works? 'Cause I've never understood that whole system.
No, actually I can't. I could look it up and refresh my memory, but I'm not going to try to bullshit my way through it. I guess look at it like this. There's permanent magnet generators, which have a permanent magnet and rotate a coil of wire through the magnetic field, and the wire cutting the flux induces current and makes electricity, right? But if you don't have permanent magnets, and then you use an electromagnet to make the magnetic field. So you have an exciter coil that creates voltage that runs electricity through a coil. Now you have an electromagnet, and I believe the reason they did that was on this. I'll bet you your generating coils, your field coils,
Right.
are stationary,
Right.
and the electromagnet is a rotating armature in it.
So the whole stator and rotor thing.
And you know why they do that, right?
No.
Because if what's generating the electricity doesn't move, you don't need
Brushes.
Brushes.
Right. Okay.
So then you've got a big stationary electric coil out here connected to your output, and then this creates a current which makes the rotor into an electromagnet. It's probably much easier and lighter to rotate an electromagnet than giant permanent magnets.
Right.
So all about efficiency and not having brushes and shit. If we look down here, that's that dang vacuum pump we were hanging out when Ted was explaining stuff to us.
Right.
So that's pumping the air and non-condensable gases out of the condenser. Somehow in that condenser, river water's cooling off the steam, and some of the water goes back to the river, and the rest of the water goes back to the boiler room. I'm half guessing this might go back to the boiler room.
Makes sense.
But what I didn't get, and we're going to have to do a little bit of internet research because I want to understand it, is this condenser over here, I understand. It's a shell and tube heat exchanger, right?
Right.
Cold water in the pipe, steam hits the outside of the pipe, steam isn't steam anymore. This one, Ted said it's not actually a heat exchanger, and that there is some amount of mixing.
I think it's a contact condenser. It's like a spray.
I'm unclear how that works, because on the other hand, river water is incredibly dirty, and if you've got feed water that you're reutilizing, you've probably filtered it, cleaned it, treated it somehow to minimize all the problems with dirty water and hot surfaces. Because it takes that much of a practice. Have a great day.
So are these the outputs of the...
Stem in, electric out. My guess.
Okay.
Guess only. But I mean, obviously, turbine section, generator section, I'm sure those are wires
Yeah.
or conductors. And I'm sure that what goes into that copper, brass looking piping
Copper.
must be electricity. Chris, interesting.
I
enough-
think those might be liquid cooled conductors.
Okay. Remember over there when we looked at the governor linkage that was on the end
Right.
of the turbine shaft? Look up there. See
Yep.
that beam and that long rod? And as we move around, you're going to see that long rod comes down to a very similar governor setup as we had over there. And that governor setup is going to control the steam admission. So you can get a look at it on that one over there.
I like the best of both worlds. There are days when I want to go out and like, there are days when I want to go out.
Whoa. That step's a lot longer than I remember. Ugh. Oh, hey, it's open. Go that way.
Oh, I will in a minute. But you can see that linkage rod comes down, and then right there behind the steam pipe, actually in there above the turbine, between the turbine and the generator, is a whole bunch of linkage. That's going to be your governor system. And then there's a bevel drive gear on the steam admission valves right there. Right, see that? Those two 45-degree gears?
I'm going to take your word for it. I can't see them from here.
Oh, come over here.
Okay.
See that round horizontal shaft coming
Right.
out in the gear teeth? That shaft would be controlled by that governor assembly in there, and by turning would open and close the steam pocket valves and control steam admission to the turbine. Same thing's happening here with the rack and pinion gear. So that rack and that pinion will work those poppet valves for steam admission to the turbine, and that whole assembly is controlled by a governor arm that comes down from the top and works all this governor linkage inside here. And what you're looking at in there is the shaft, turbine, generator. That's the power transmission shaft up into the generator, and this is your steam admission valve and probably an emergency hand trip painted red.
In case of oh shit.
Yes.
And this part's all new because this wasn't open last time we were here.
Turbine end of things, and then my friends would be on the boiler side. We got back.
First time here?
Absolutely.
Oh, good. Welcome. Simply a steam room, water room, making steam. Three different units.
Yep.
Turn the generators, turn the turbines.
Yep.
Generators on top made the electricity.
Yep.
And it went to the distribution panel on the far side of the building
Yep.
before it went to the grid.
Okay.
Generated DC, it was switched to AC.
Are these just two very large, long boilers?
8 to a side, 16 of them.
16 boilers.
Yep.
Fuel oil piping here?
Yes, started out with fuel oil, 1906. Went to coal, 1917, because of the war. And back in the early 50s, went back to oil in an attempt to be more clean and friendly for the pollution. One boiler, the one over there, is set up with natural gas.
That would be the second one
Yep.
over there that has the different inlet
Yep.
piping?
And that's, City of Seattle uses that for boiler certification and recertification.
Oh, for training and certifying boiler operators?
Yep.
Okay. So is this just a little access into the fireside? So you can
Yeah, there's you can see one of the chambers. I got a flashlight here if you want it.
I do. I absolutely do.
Stick your head in. You know what you got. You know what's in there. You and these two guys?
Yes.
Condolences.
Thank you.
So, Chris, that's what you'd probably call the water drum.
Yeah.
Because at the bottom of the boiler, you have
see
a
the-
water drum where the feed water is, and then the water goes up through those vertical tubes you see in there.
The risers.
Up, well, those are actually probably generating tubes. aren't
Okay.
Rising to the next drum up there.
they? Yep.
To the steam drum.
The water and the steam is separated better.
Yeah.
Before it went into the.
Yeah.
So,
So
is one side steam tubes and one side, or where are the downcomers?
The downcomers would be somewhere else.
They have to come back into this tube, don't they?
Yeah.
Into this vessel?
Yeah, they're probably at the ends.
Okay.
Or they're coming in through the bottom. It might feed in through the holes in the bottom.
Just
But
one.
interestingly enough, when we clean, we'd have to crawl in those and work in there both, if we had a tube
You're on the
fitted,
wrong side.
if we'd failed out a tube, you'd have to crawl in there and go in on the fire side and cut out the tube, and then go in on the water side and grind out the tube from the tube seat, and then press new ones in. And when you clean the water side of a boiler, you're crawling around in there with a rotary brush mechanism. They call it short punching, but you're cleaning the bottom end of the tubes manually. It's horrible, nasty, dirty work. And makes you wish you were smart enough to be an IC electrician.
Although, as an electrician, I had to help re-brick a boiler that came down on the tender. Because
Right.
our gear, a fire eye, didn't shut off the oil flow. when
Fire
the
eye didn't
went
shut
out.
off. Oil kept flowing, little boiler explosion.
Yeah.
Flashed it off the
It was a
wall.
600-pound boiler for hot water.
Yeah.
So,
Still, it can be a bad day when those things happen.
Yes.
So Chris, you see these chains? I'll bet I know what those are, but you'll go correct me if I'm wrong. So when you're burning your boiler, you get soot on the outside of the tubes, and that soot's a great insulator,
Right.
and it'll slow down your heat transfer. So these are probably steam pipes that go into nozzles called soot blowers, and every so often you open these valves and then pull these chains, rotate that soot blower head into 360, and steam blowing in on the fire side of the boiler blows the soot off the tubes.
okay. How is the
Like every 24 hours on a Navy boiler.
how is the draft created on these?
Part of the main draft control when it was cold are these panels there.
Okay.
So it was natural.
It was just a natural convection?
There
Natural
was-
convection.
There was no forced draft for combustion air.
Not until they put Boeing Field expanded this way and they put the short stacks up there. You'll see them when you leave.
Okay,
There's 8 short stacks.
on the roof?
Yeah, and that's a forced ventilation system
Okay.
for expelling.
Just operated by heat, just thermal ventilation.
Yeah.
So adding a stack, the exhaust gas is going higher, faster, which draws in more air essentially. Okay.
Because they had like a couple 100-foot stack here before Boeing Field was this.
Oh, okay, then they went to the short stacks after Boeing Field got big.
Expanded this way.
And what's this over here that was behind us on the,
That and that are feed oil heaters. The oil is just enough to flow.
fuel oil heaters? Because the fuel oil back then was so thick and gooey that if you didn't heat it up, you couldn't get it to, well, it wouldn't flow and then it wouldn't atomize, yeah. Yep. We preheated the fuel oil even on the Flint, Chris, even though it was DFM, because if it was warmer, it atomized better and burned more efficiently.
The Dad's destroyer, they had to do it. The BTs did it all.
Yeah. Well, on the destroyer your dad would have been on, that would have been a real old black oil destroyer, practically burning tar.
Exactly.
Yeah,
No hearing.
yeah. Thank you.
You're welcome. Come back and see us again.
Oh.
Second Saturday of every month.
I will be back. This is fascinating.
We'll bring friends. They may never leave.
Fuel oil pipe. A lot of times you have a supply and a return because you've got a constant flow.
Uh huh.
And this is a burner or an atomizer. Fuel would come in through here, spray out through here and just be burning like crazy in there, just a jet of raw fuel combusting in the boiler. One of the jobs we had to do in the Navy was our sprayer tips were way different, but every 24 hours you had to change out the burners and clean the sprayer plates with a brass scraper and a brass brush so you wouldn't damage the holes. And then that gentleman over there was opening the door, but these chains just
Natural convection for the.
open the doors, open the draft doors to let in.
Wide range of boiler size.
300 psi. I don't know if I can get the light on that. It's interesting.
So what does that actually mean? Economizers are feed water heaters?
They're essentially a feed water heater. You run your feed water through shell and tube heat exchanger.
Right.
In the Navy, we called it the uptakes. But at the very top of the boiler, after you've already extracted all the heat you're going to extract for steam, your feed water runs through a heat exchanger up there and uses basically the waste heat in the exhaust to preheat the feed water before it goes down into the water drum right over there. Navy, we called that a mud drum because not only is that where the feed water comes into the boiler, but it's where the sludge and stuff collects.
Right.
So these would be natural gas burners. Natural gas inlet valves. It's interesting they still use this one for training.
It's got to be a pain to take something offline for training, so if you've got this plant that...
And then each boiler, see the doors in there? Those are just what we went into over there. These individual boilers are not dissimilar in size from the individual 600-pound boilers on the front. We had 3 of them, and they were, the ship was 80 feet wide, and 3 of these would be with gap between them and outboard. Yeah, they were about this size.
So your boilers ran transversely?
This would be, the keel would run this way.
Okay,
And
so
the
yes.
boiler, 3 boilers set side by side across the width of the ship. I have no idea what that is.
Pressure gauge over time. It's a circular recording pressure gauge.
That's cool.
I've got a temperature one at home that's clock wound, like your dad used to use when he was driving truck.
Yeah. North Coast Engineering Company, Seattle, Washington. I like how they tell you it's 2-pound subdivisions. Well, that's 30, 40, 50, 60. Yep, pretty much. It's weird not having a draft gauge because everything I worked on had forced draft.
Well, that's an efficiency for size thing, isn't it?
I'm not up on the design parameters and the how and why. What's 16 times 53?
800 and change, 850.
So that's not, that 53W that's on every boiler is not 53 watts. Can't be. I love the light bulb on the pressure gauge on each boiler. Somewhere way up there is the economizer and stuff, and also somewhere way up there will be some relief valves and stuff.
Well, there's your main steam valve for this bank up yonder.
Notice the springs on the pipe hanger there, the big coil springs where that pipe's mounted to the concrete.
Yep.
You'll find that all your boiler pipes have big loops and bends in them.
So when you open and close, it kicks?
So they can expand and contract with with heat.
Yep.
They get bigger when they get hot. Mm-hmm. This is interesting. I thought it was an air compressor, but it's not. I know it's not an air compressor because air compressors wouldn't have fire brick in them.
Some kind of a starter boiler, maybe?
It is some kind of a boiler. I'm sure of it. Hot. This is a burner assembly for it. Here's your sprayer plate. This looks like an electric blower, like an actual force trap blower.
Well, that makes it somewhat later, too. I would think this might be for getting it going, because don't you have to... You don't just throw a lit piece of rag in these, do you?
Yeah, you kind of actually do.
Oh, okay.
Well, the boilers I operated, you would have a hole that you would open and a long metal rod with a lit rag on the end of it, and you would light it and stick it in, and then you'd hold it in there, and then you'd open this valve and spray in some fuel and get it lit, and then over time you'd slowly heat up the boiler until you were making steam. What I wonder about this, Chris, is when you take a boiler offline.
Oh, you know what that's for?
Yeah, it's for layup.
No. It's for heat.
Okay.
That's just for heat. That's just for
It does more than that, though. You wouldn't have that big of a boiler for that little heater, would you?
I don't see it going anyplace else.
Yeah, see, look at this white line here that goes back
That
behind.
way?
Yeah. So
It's a big building.
you could use it for heat when the boilers were shut down. But when you shut down a boiler like this, you can't just depressurize it and leave water in it.
Right.
Because it's iron, it's going to rust.
It's also potentially going to freeze around here.
So we would, in the Navy, pump steam from the operational boiler into the shutdown boilers to keep a certain amount of temperature and pressure, called a steam blanket layup. And I'll bet the reason that there's steam lines from this that go around the plant a little bit would be when you shut down the plant to be able to have steam to put the boilers in the proper layup.
Makes sense. Is that a valve in the ceiling up there?
A valve.
See the light? I don't think it is. No, it's a hanger for something.
I think it's, yeah. Hey, Chris.
Huh?
The motor on that heater blower is newer than the motor on our blower in the shop. Speaking of that, we really
We need to replace it. I know. Yes.
Well, we've got the motor. We just
Need to make a mounting.
Well, we need to take the one apart and see if the shaft sizes are the same.
There's the expansion loop.
Yeah.
I don't know how well I can capture that, but
Somewhere probably up on the catwalks on the upper level where we aren't and where we can't get would be some fairly elaborate and detailed water level measuring and monitoring devices. Maybe as simple as sight glasses, maybe as complicated as having some automatic shut-off feature. Because high water, in which if the water level gets too high, you carry water out with the steam and dump it into your turbines,
that's a bad day.
or low water where the generating tubes are no longer kept full of water and you overheat. Both are like the two most catastrophic things you can do to a boiler.
Yes.
That stuff must be on the upper level, but we can't get to it. Here's a better look at the soot blowers.
Yeah.
Oh, I wish I could go to the upper level.
I think a lot of us would like to get to the upper levels.
Yeah.
Yeah.
Are you a steam plant guy or just
A photographer.
photographer The boilers on our ship I was on were about the size of these boilers. The functionality was remarkably similar.
That's what we all have.
Whoops. You can get back here. It's not off limits. So, right there, that's a water drum,
Yep.
and those are generating tubes. And that is the fire side of the boiler.
That one there in front of us, just to the left, is a little corroded.
Yeah, just a little.
So basically how this worked is, this is just a big box. It's concrete lined with fire brick.
Right.
And these have essentially like a flamethrower on that side. It blows oil in that burns. These tubes, this drum at the bottom, these tubes go to the drum at the top, will be full of water. That water boils.
Right.
So it's basically exactly the same as your kettle on the
I
stove,
was gonna say, yeah.
just with a lot more surface area, so it collects heat more efficiently.
Oh,
It's identical all the way down,
Yeah.
but cool as fuck nonetheless.
No, I wish I brought the Cinepole.
oh, yeah.
Could have stuck it right down through that hole in the floor.
It's weird. I wonder what's below the boiler.
Waterproof boilers in here, so they've been toasted, especially in the summer. Weather wasn't bad. These boilers started out working on oil and
Something amuses you.
Yes, yes. This is one step above a parakeet in a bird cage in a mine, I think. It's CO2 monitor. 0%, 20%. Red light. Loud, noisy thing. When this needle gets to a place where it's bad for you, it says go away. That's all it is. Mm-hmm. I'm not sure how it worked or how it monitored it, but it's neat because of its simplicity, right?
I love these chain controlled valves.
Yeah.
actually, that's a water meter.
Is that a water meter? Okay.
Simplex
Once
water.
they went to city water, they had to put that in after the river got moved away.
100,000 pounds per water, rate of flows. Is that feed water flow?
Yes.
Probably feed water flow, yeah.
Water incoming.
And I'll bet this was a drum recorder.
Yep.
Recorded water use. And those would be just like an electrical meter.
Yep.
100,000s, 10,000s, thousands, tens, and ones or something, and the ones spins like a freaking electric fan.
Does that help at all? Or would-
Yeah, that helps a little bit. So tell us about the feed water here. How much was filtering, processing, recycling?
Don't know, but they tried to, after the steam was spent in the quote generators, it would go to the condensers, it would come, so it'd come back into water and would get recycled, flow back into the system here.
Yep.
Some was lost through evaporation, some was dumped. What percentage, I have no idea. It probably got better over the years, but
Well, in the first
the
two...
river was right beside us at one time. That's why they built it here.
I did not know the river used to be this far over. But then the first two turbines, also the vertical turbines, the gentleman we were talking to, Ted, seems super knowledgeable on this stuff. He said those used a direct contact condenser, so some of the feed water actually got mixed with river water. And then the third turbine, the horizontal turbine, uses shell and tube heat exchanger type condensers, so that would have been more efficient, keeping the river water completely separate. I'm going to actually go home and look up contact condensers because I've never used one, and I can't figure out how it worked.
Yeah, it is osmosis.
Yeah.
I think it was more like spray nozzle.
Yeah. And, you know, and the horizontal is 10 years after these were put in, to 12 years, and it's
Yeah.
changed dramatically. the
Yeah.
technology.
Yeah, the technology was
And the
advancing
generation.
rapidly.
Well, and the horizontal that was put in, you know, when did that go in? 1915 or something?
15 or 18.
Yeah.
Can I chase you guys into the light where I actually can see something here? Sorry.
Well, that horizontal that came in then is essentially the same design that they were using for marine turbines, clear until they got rid of marine steam propulsion turbines and everything went diesel and gas turbine.
Yeah.
You know, up through the 60s and 70s, the boilers the Navy was using were that same design.
Pretty basic stuff.
Yeah.